Okay, so what I'm going to do is going to go ahead and turn the screen over to the presentation mode. We'll start with a little refresher of some of our important symbols. Then we're going to go into Chebyshev theorem and the empirical rule for today. You're not going to see anything for just a minute. I'm switching over the screens. Okay. And I've got, let's see here. One little change I have to make. Perfect. Okay. Here we go.
Yep.
So Stephanie, we're going to start with you at number 2. And so we're thinking about the symbol we've got, the X bar. And as we're looking at the questions, this is very similar to what many of your exam questions are going to look like. I'll probably have like 6 or 7 questions. I'm just going to ask you, here's the symbol, what does it mean? Because that stuff really it comes important in later chapters. Okay, so Stephanie, which one do you think for X bar?
Population average?
Okay, she's going for population average. What do we think, everyone?
None of the above.
Okay, here are none of the above. Anybody else?
None of the above.
Okay.
Well, isn't it the same? Isn't the X, wait, the X bar, hang on.
Take your time.
I
It's
thought
okay if
X
you look in
meant
the notes, guys.
population.
I think that's mu.
Sample mean, middle number.
So what do you think the answer is, Stephanie?
It's not range. It's none of the above, E. Right? Because it's the mean.
You got it right.
Okay.
You're correct.
Okay,
And
thank you.
answer A isn't correct because I think that was, oh, I don't see the name on the picture anymore. But A, our eyes jump at the word average. The problem is it has the word population in front of it. That's what's the disqualifier. And I'm trying to move the chat window so I can see people trying to ask something. Okay, good. So the next one we have is Alex. Alex is number 3. Alex, this one's yours. Can you hear us, Alex? Okay, Alex might not be in the class. I'm going to go to Talia, number 4.
That's the mu, so.
You got the name right. That's good. That's helpful.
Is it D?
Say again?
D?
Like Charlie?
No,
okay.
D as in dog, like population average.
Oh, like delta. You are correct. Yes, that's the population average. There it is. Okay, next one is going to go to Natalie. She's number 5. Natalie, this one's for you.
The standard deviation, so E.
Okay, she's going for population standard deviation. And what does everyone think? Does Natalie have it right?
Yeah.
Yes.
It's just, is it just standard deviation?
Oh, that's a great question.
None of the above.
Sort of. None of the below, but same.
None of the below, yeah.
I'm probably the only professor that's ever going to write a question and say none of the below. You're correct. We thought about standard deviation, but it belongs to which one? Population or sample?
Sample?
It does. It belongs to your sample, and sample standard deviation isn't listed in there. Okay. Anybody have any questions about anything we talked about so far before we move to the next?
All right. About the test.
Sure.
Do you have a study guide on Moodle, or is it just based on what we've been learning in the book and the homework?
It's that's a very good question, and it's based on the exact same kind of exercises we do in the lecture here, and it's also based on the highlights in the PDF packet.
Okay.
And remember, everyone, your test is going to be some multiple choice and some working answers. I mean, like questions where you actually have to fill something out by hand computation. The multiple choice questions are probably a decent amount of your exam. Between that and the working questions, the area where most students make the mistakes is actually the multiple choice. To prepare for those, the best way you can is obviously things like we're doing right now. For example, tomorrow, go and watch the first few minutes of the same video and see if you can get the answers right. When you see the highlights in the chapter, make sure you can cover all that up and explain it to somebody else. Like, can I see variance highlighted? Can I spend 2 minutes telling somebody what the computation is and explaining it? If you can do that, then you're in really good shape for the exam. A lot of people will wait until the night before the test. I'll look over it a little bit. I can always look back and fill it out. Those people get like a 40 on the test. So somebody's asking me, they're trying to get into the video. So I'll do that in just a second. See if we're gonna go through one more here. I think we're up to Zachary, number 6. So I have to do something to switch screens. Zachary, this question's yours.
Is it
Oh,
population standard deviation, E?
okay, he's saying standard deviation. Now that's not correct, but what would it, how would we have to change that symbol to make it a sample standard deviation?
We'd have to do the square root.
Yeah, exactly. As a S squared, that's going to be a population variance. And to get that, Zachary, into sample mode, we would have to get rid of the square and just have it as plain old S, like Sierra. Make sense? And I'm gonna,
Population variance.
well, the way it's written in now, it's a sample variance.
Okay. Oh, okay.
Just to clarify, in case I misspoke,
Mhm.
if we want to say sample standard deviation, we would have to remove the square, and that would
Mhm.
make it the same question the one on top was.
Mm-hmm.
If we wanted to say sample variance, we would have to change the entire symbol out altogether. Okay, I'm going to go down to Amanda here. Amanda is number 7. Amanda, this one's for you.
False.
Okay, she says false. If the variance is increasing, our data set is getting more consistent. What do you think would be happening if the variance was increasing?
Wouldn't that mean that the numbers are more far apart?
Right. You're exactly correct. So they would appear more jumbled up. They'll be going up and down in leaps and bounds from one number to the next. Okay, good job on that. Austin is next, number 8.
Say true.
This one is false. What makes it false? It's very closely related to the one above it. The answer is the standard deviation and the variance are almost joined at the hip. The standard deviation is the average distance each value is from the mean. The variance is the average square distance each value is from the mean. So if the standard deviation is increasing and your numbers are getting further spread out from the average and more widely dispersed, the variance would have to be doing the same thing. So once the standard deviation increases, then it means the data set observations are getting further and further and further apart from each other. Does that make sense, Austin?
Yes, thank you.
All right. Okay, I'm just checking the chat window to make sure there's nobody that has any questions. Everybody good so far? Okay, we'll do just a couple more of these, then we'll get into the Chebyshev theorem. Here's something we were talking about before. This goes to Deanna, number 9.
Is it the population variance?
You are right. Well done. Okay, and this one is for Moshe, number 10.
This is the total number of observations.
Keep going.
The sample.
All right, well done, Moshe. Okay. All right, so what we're going to start to do is we're going to talk a little bit more about the whole Chebyshev theorem. We'll just refresh a little, reacquaint with it, and keep remembering to go through the symbols. Make sure that like every, twice a day, 3 times a day, bring them on flashcards, keep taking them out. Because what we're going to find is you learn them during lunchtime, and then what happens by dinner time?
You forget.
Yeah, you're going to forget everything. You study them up by the end of dinner. Oh, I know this cold. Go to bed, wake up in the morning, you're going to forget it all again. So it's really helpful to keep going through them as many times as you can in one day. All right. So we had mentioned a little bit about Chebyshev, and we went through this slide earlier.
Please take the 2 seconds to hit the little button that says like thank you. It literally, you hit one button, it thanks them for gifting you a sub.
If you would, if you are not speaking, please go ahead and mute out your microphone.
Love back to the people that are
Someone's
going
having
out.
a whole conversation back there, and it's thank you very much. Excellent. Okay, so Chebyshev theorem. I'm going to ask Ji-Woo this. She's number 11. Ji-Woo, what kind of stuff, what kind of data set will Chebyshev theorem work on? This is something we talked a little bit about in the last class. Like, does it have to be bell-shaped, or does it have to be uniform-shaped, or what happens in there?
I don't know, sorry.
Okay, anybody else who wants to shout out?
Works on any
Any
data?
data set?
Outstanding, that made me proud. Yeah, it works on any data set. You just have to know the average and the standard deviation. Eventually, you're going to get into other formulas that do the same thing that the Chebyshev theorem does. The Chebyshev theorem is just out there to tell you what minimum percentage of data you're going to find in a certain range around the average. There's going to be other formulas that sound very similar to what Chebyshev will give you. How do you know that it's time to do the Chebyshev theorem? What's that dead giveaway in the question?
It says at least.
Yeah, it's going to say at least or the words minimum. And that's really important. If you forget that, you're going to spend like half an hour trying to figure out how to do one question that has several different possibilities for formulas, and you want to expedite your way through the test. So those keywords will help a ton. And we also found out that the Chebyshev theorem said if we go 2 standard deviations above and below the average, we'll get at least 75% of the data in the data set. If we go 3 standard deviations above and below, we'll get 89% at a minimum. I'm going through this part kind of quick because we had seen this in the last class. We found out that the Chebyshev theorem worked because the inventor made this variable k, and k is the number of standard deviations that you're going to travel from the mean. And when you make this proportion, the proportion says if you stick in the number for k, you'll get back a percentage that looks like a decimal. And that's going to tell you how much of your data, at a minimum, you'll capture in the percent. So when we stick in 2, the proportion will tell you 75%. And we're going to do the algebra, don't worry. We're going to work all through that today. So when you're trying to find out between what 2 numbers around the average do we get that 75%, we're going to have to go into the question and dig out some information. We're going to need to retrieve the sample average. We're going to need to retrieve the sample standard deviation. And when we take x bar and add it to k times the standard deviation, that's going to give us the high number of the range. X bar minus k times the standard deviation will give us the low number. I realize this is very abstract right now. It's hard to get your head around it. So we're going to go to a practical example right now. Before we do that, any questions on what the idea of the Chebyshev theorem is?
At the formula that you're always going to use?
Yeah, exactly correct. There's two pieces to it. The first part is the proportion. The second part is the range portion. And you're going to use the context clues and the information in the question to help you figure out which formula to use first. That's part of what we'll talk about today.
The X bar, is that plus or minus KS, or is that just plus negative KS?
You're correct. It's plus or minus. It's plus or minus because there's going to be a high side to the range and a low side to the range. So that's how they're basically taking the X bar minus KS and X bar plus KS, and they're compacting it to one formula. Any other questions anybody has? Okay, so we're going to go ahead with a example here. I'm going to give you guys a minute just to copy down information if you want. If anybody's hungry, you'll probably really like this one.
Mhm.
And I see somebody, the person with the T-Mobile hat is enjoying a bagel right now. We're gonna ask you how many calories it has in a minute. Okay, if you need more time, just scream. I can stop for another few seconds. So what it's saying is we've got this stuff about bagels here, and they're telling us the average number of calories in a regular size bagel is 240. Standard deviation is 38 calories. And we're looking for the range where at least 75% of those calories are going to be. And there's something in bold that's highlighted. That's because you want to start to train your eyes to look for those key words. We're going to say they gave me an average. They gave me a standard deviation. They said the words at least. I think I know. I'm going to go straight to a Chebyshev theorem question. Okay. So what we're going to do is we're going to take this proportion and we're going to get ready to solve this for K. Once we have the values for K, then we're going to plug them into the minimum and the maximum formulas to give us our final answer. Now, to start with here, there's a really special trick that you can use that'll make your life a lot easier. What we're going to do is first, we're going to write the left side as proportion. Now, when we're thinking about the right side, what's going to be easier to work, everyone? An inequality or an equality? Like, on what side do you think the algebra is going to be easier? Fast answer is that equality is going to be a lot easier to work. So what we'll do is we're going to change the inequality to an equal sign. And at the end, when we summarize the information, we'll remember mentally to go and start saying the words at least or minimum. That's really going to help us streamline the algebra. The next big thing I like to do, take the 75% and change it into a fraction. That can help you avoid a lot of mistakes. Because a lot of students they'll do funny things with the 75%. They try to put it in as a whole number, as 0.75, and they can really mess you up in the algebra if you handle it the wrong way when you're solving for the K value. Different questions, by the way, in case you're wondering, they're going to have different percentages. And we happen to know K equals 2 for at least 75%, but we're going to pretend we don't know that so we can practice how the algebra would work. And I'm up to Jaleesa now at number 12. So Jaleesa, when I'm looking at the equation from left to right, we want to isolate K, but what's in our way first that we have to kind of get rid of the left side? Oh, excellent. Good job, Jaleesa. She says 1 minus. She's exactly right. So how do we get rid of that 1? Like, how do you clear out the 1? What can we do? Let's work the algebra magic here. I'm going to stay with Jaleesa. Or anybody want to help her out? What do we have to do to clear out the 1? What's going to make it go away?
We have to subtract it from both sides.
Outstanding. Yeah, we have to take it away from both sides. So on the left, I'm going to do -1 plus 1, -1 over K squared. And what I do to one side of the equation, I have to do to the other side. So on the right side, I'm going to go ahead. I'm going to do 3/4 -1. And that's going to clean up for us. Roberto, number 13, what are we going to get on the left side?
Hello.
Hi.
Um. I'm confused. I don't know.
Well, you got the numbers in green. Can you see that well on the screen?
Yeah.
Okay, great, great. So when we look at the left side, the -1 plus 1, what's it going to turn into?
It's going to turn into 0.
Exactly correct. Yeah, you are our subtraction specialist for today. So we're going to go ahead and do -1/k². On the right side, we're up to an arrow now, number 14. What do we get on the right side?
Uh, 3.
We've got 3/4 minus 1. Anybody want to give them a shout out?
The -1/4.
Exactly correct. Yeah. And we're going through this really nice and slow because it's the most commonly missed problem on the test. People get really weirded out by the algebra. So this is for us to geek out for a while and do the algebra line by line by line. So we're grandmasters when we get to the test. And then we just get to the next question and we say, all right, got all the points. Great. Okay, so we're at -1/k² equals -1/4. This is looking better because we're closer to having nothing but k on the left side, but we don't want to walk around solving for negative stuff. We want positives. So Ashley, you're number 15. What can I do next? What can we put in there to get rid of the negatives? And Ashley might not be here. So I'm going to go to Aileen, and I see Aram has a question in there. I'll get back to you in a second, Aram. Eileen, number 16. What can we do to the whole equation to get rid of the negatives and clear them out? Okay, I see Jaleesa coming in. I don't hear Eileen, so she might not be with us. And just Jaleesa saying subtract both sides. Can't see what that is. I have to move some windows. Subtract from both sides. Flip screens here. Okay, Jaleesa, what do you mean by subtract from both sides? You mean do some kind of minus operation on the left and on the right? What can we multiply both sides of the equation by?
-1.
Yes, that's it. We're going to do -1 times -1. That's going to give us 1/k² equals 1/4. And Aram, for your question, the way you wrote -1 minus 3/4, what you did was you changed the sign on the 3/4, but you left the 1 where it was. So you reversed one of the signs on the numbers. And it's going to mess you up when you try to finish the solution. If you want to change the order, you would have to do -1 plus 3/4. I see that you wrote a question about the subtraction to the chat window. That's what that's about. Okay, so 1/k² equals 1/4. This is something more easily handled to solve for k. Before we get there, anybody have any questions about how we did it? Okay, so what I'm going to do is just write this further up on my screen, get some room. I have to move something around here. Did that work? When the chat messages come up, it goes, the window pops open. Sometimes it covers the screen, and I got to move things out of the way for a sec. Okay. If we cross multiply this out, we're going to get, obviously, k equals -2 or k equals +2. But since we're doing distance, we only want the positive k equals 2. Any questions on how we got here? Okay, so now we know that k equals 2. What we have to figure out is how do we finish? So we got that K value. What are we going to do next with the K value, William? I got William as number 17. This one's your question.
I'm not quite sure, Professor.
So once we solve the proportion, we know K. What's the only other formulas that have a value for K that we couldn't solve because we didn't know? And the answer is on the top of the screen.
X minus K S.
Yeah, that's it. That's it. Exactly. Now we
Yeah.
can solve for the minimum and maximum because we knew everything at the start of the question except what K was. Now that we found that out, we're cleared for tables. Okay, so we're going to we're going to take that maximum side, and I've got to juggle the screen again here. Okay, going to take that, starting off with the minimum side, and at this point, all we're doing is plugging in the information from the question, the value for X bar and the value for S. We get 164. What do you guys get for the high side? As soon as you get it, you can just shout it right out if you like.
316.
Okay, let's see if we are correct. Yes, 316. Well done. Only difference between the minimum and the maximum is going to be that sign change. I know it looks kind of complicated because it's this big whole theorem, but really the only difference between the minimum and max, we're going from a negative to a positive. Any questions so far up to here? Okay, let's do something kind of cool. I think I'm gonna bring this to number 18, that's Shannon. So Shannon, this question is for you. It's an analytical question. Going into it, it's about the data we were just using, a practical example of applying it. We know that at least 75% of the bagels are going to have between 164 and 316 calories. And then you go into the supermarket and this is what happens to you. You find this slogan on a bag of bagels. And it looks like a really good bag of bagels to buy you for breakfast. And then we're reading the number of calories and they're telling us they got 310 calories in there. And there's big thing written on the bag, like best low fat calories in town. So using what you know from the Chebyshev theorem, would you believe the slogan, Shannon? What do you think?
No.
Okay, see a lot of people shaking their heads. No, how come? What would stop you?
Because it says that at least 75, it ranges from 164 to 316, and it's high on the scale. It's up close to it's the most fattiest one on the scale.
Good. Well done. Good use of statistics to figure out buy or no buy decision. And that's exactly correct. How about if we did this? I'm going to stay with you.
Yeah, it's a lot closer to being low fat.
Okay, right on. That's exactly correct. I think this question is really kind of cool because people are getting better and better at making informed buying decisions. At the same time, do companies try to play games with their slogans, everyone?
Yes.
All day long. Yeah, they sure do. Okay. We're going to take another Chebyshev example to work through. Any questions so far on anything? Okay. So now we got a slightly different one. We're doing mazes and mice here, mice and mazes. I'm going to give you guys a minute to read the question. What makes this one look really different than the last one? I mean, besides that the actual numbers are different, what's kind of like structurally different here? I'm going to go with Stephanie. She's number 19.
There's no percentage?
Yeah, exactly correct. Well done, Stephanie. Very perceptive. So if there's no percentage, what do you think is going to happen differently when we go to solve it out? What formula do you think we're going to have to use first instead of what we did before?
We would have to, well,
Like, we know we can't use the proportion because it's useless to us right now. So where's the only other place to go?
start with 1 over k squared.
Well, that's the proportion. That's the one we can't use because we would need a percentage to move it along. Since there's no percentage, what do we have to start with on the other side? I mean, in the alternative.
I don't know, maybe the standard deviation?
That's it right there. This is really important because a lot of people miss this question on the test. They don't see a percentage and they kind of shut down. Gosh, I'm not sure how to solve it. All it means is that they're asking us to find the percentage. That means our job is first, we're going to have to use the formulas on the right that are circled to get a k value. Then we'll take that k value, we'll put it into the proportion. And I'm going to stay with you, Stephanie, for a couple minutes. We can solve either the minimum or the maximum side, everybody, to get our k value. Now, Stephanie, what would you rather do? Work with positives or negatives?
Positives?
All right, I like your style, so would I. So what we'll do is we're going to set up with the maximum equation, and we're going to have to solve this value, solve the expression for k. Now, what we'll do is algebraically we'll move it around to get k isolated, and then once we know how to get k, we'll go ahead and we'll plug in the numbers. So when we're reading this thing from left to right, we're thinking about what's in our way. We want to isolate k. It's on the left side. We'll keep it on the left side. But Lauren, what's in our way that we have to get rid of in that equation first?
We have to get rid of the x bar, which is 12.
Yeah. So if we limit just what's happening to the symbols, you're exactly correct. We have to subtract the x bar from both sides. So here it is on the left. When I do the one side equation, I'm going to have to do the other. So on the right side, we're going to do the maximum minus x bar. And what's this going to give me for the left side, Kayla? Kayla's number 21.
Sorry, could you repeat that?
Yeah, what do we get on the left side?
I'm not sure. If you subtract the max, you would subtract the bar?
No, just on the left side, we're working first. So it's minus x bar plus ks.
You would just get ks.
Exactly correct. So we're going to say kx equals maximum, and I think I had something covered on the right side of the screen. Might have been what slowed you down. Okay, kx equals the maximum minus our x bar. So to get to the very end, Isabel, number 22. Isabel, what's k finally going to equal to? We're going to have to do something to get rid of the s. So if the s is being multiplied by k, Isabel, what are we going to do to, like, what would destroy the multiplication?
Dividing?
Yeah, I think you said divide.
Yeah.
You are exactly correct. So what's the right side going to be?
I don't have the answer to that.
Well, it'll be the maximum minus k bar, or I'm sorry, the maximum minus s, and then what I do to the left side of the equation, I have to do to the right side. So if I divided the left side by s, what am I going to have to do to the right side?
Divided by s as well?
Beautiful, yes. You're going to be our division specialist. So we're going to say we have maximum minus our x bar divided by s. And now we're ready to start filling in the values for k here. Questions Anybody, comments, concerns before we work into the next stage? Okay, so I'm going to put this up here on the side of the screen. Here's our K equals maximum minus X bar divided by S. And we fill in the numbers. Oops, I hit the button too soon. We fill in the numbers. We're going to end up with 2.67. Now that we've got the K value, we're going to go back to this proportion here. We're going to fill it in. And I'm going to stop for a minute. I want you guys to take a minute or two, work out the value that you get for the percentage, and let me know what you get. I see a few people that look like they might have the answer. If you think you have it, let us know. You can say it into the microphone or you can send it through the chat window. Does anybody need another minute or two? Okay, what did we get for our percentage?
86%.
Okay, that sounds just about right. Did anybody else get the same thing? I'm going to go and put in what it looks like we're going to be starting with the 1 minus 1 over 2.267 squared. And we get exactly 0.86 or 86%, which is what you were just saying. Anybody confused on how to get to the 86% part or the 0.86?
I am.
Okay.
I was confused how you got to that. Sorry.
Sure. So let's talk about it a little bit. And when we started, we just had it down to here.
Mm-hmm.
Are you okay with getting here, like knowing how to take the formula and put in
Yes.
the value? All right, excellent. So first thing we're going to do, I'm going to do it on my calculator at the same time. I'm going to square 2.67, and what do you get?
7.1289.
Okay, wow, you're faster than me. Yeah, 7.1289. Now I'm going to do 1 divided by 7.1289, and what do you get?
That's where I didn't do it. .14027.
Okay, that sounds exactly right. I'm getting the exact same thing. So now you've got 1 minus 0.14027, and you just need to do the subtraction, and you'll be home free. So when you do 1 minus 0.14, what do you get?
.86.
Bingo, you did it.
Thank you.
You're welcome. You're our proportion specialist for today. Okay, anybody else have questions on how to get that?
Hey, could you just go back over the part that after you got the 2.67?
Sure. This is the part where we said we know what K equals, and the whole question, like the whole point of the question, they were trying to get us to figure out what was the minimum percentage of mice that could finish between, I forget what the 4 and 20 trials. So we used the 4 and 20 part through the formulas we have circled. That told us K equals to 2.67.
Oh, okay, I got it, yeah.
Got it? Okay.
Yeah.
Anybody else have questions? Okay, so the one thing you have to keep on remembering over and over is what's the key word that you always have to say in the Chebyshev theorem? And this is, I think, Ashley, number 23. Ashley, like, what's the big key word that lets you know you have to do Chebyshev? The big annoying word.
Let's see, percentage or standard deviation? I'm not sure.
It's something else. It's that word we were talking about, like in the question, this is what would be the flashing lights and sirens to let you
Oh,
know.
the at least or minimum?
Yeah, exactly. That right there. So what that means is the Chebyshev theorem is, how would we put it? It's not very approximate because everything is at least, at minimum. And we want to get a little bit more accurate with the data so we don't have to keep saying the word minimum. This is going to bring us straight into the next topic we've got, which is all about the empirical rule. And the empirical rule is this funny thing that kind of comes in, and it says the stuff with Chebyshev and the at least theorem, I mean the at least clause, we had to keep saying that because when we were doing Chebyshev, we didn't really know anything about the data set. Nobody told us what the distribution was. Is it bell-shaped? Is it skewed left? Or is it skewed right? We just didn't know. And that's why we can't get very approximate with it. So as we know more about the data set, we're going to be able to get much more precise when we do a range estimate. And the next place we go is the empirical rule. The one thing that you have to remember, like if you forgot everything else, it would just be this. Only use the empirical rule when you have bell-shaped data sets. Inside of a question, the question would sound really similar to a Chebyshev question, except number one, they're not going to mention the word minimum. And number two, they're going to have to tell you your data is bell-shaped. And sometimes on the exam, I might give a question and say, your boss is telling you to analyze this data and it's skewed. They want you to use the empirical rule. And like you're already crushed with deadlines. What could you tell your boss? And you know what? I could say the empirical rule won't work here because the data is not bell-shaped. Okay, so what's the empirical rule say? There's two parts to the empirical rule. First thing it says is if you go one standard deviation above and below your average, you're going to find about 68% of your data in the data set. So 68%, pretty decent, more than half. If we go 2 standard deviations above, we get pretty much almost everybody. We're at 95%, well, almost everyone in the house. And Salah, you're number 24. Salah, what do you think would happen if we go 3 standard deviations?
110%. No, 100%.
We can't get that high. What's the highest we could get?
100%.
Okay, almost. Well, one tip I'm going to give you guys, like I like where your mind is. You think 2 was almost everybody, so 3 must be everyone. We're going to back it off just a little bit and go up to 99%. And only reason is because we're not going to give 100% to anybody because we're going to leave open a little chance that it's only probability at the end of the day. But otherwise, your mind is in the right spot. Okay. So this is like the full house. Almost 99% of the whole data set will be within 3 standard deviations of the mean. Okay, so let's take this and let's put it to work a little bit. Let's get a little example out of it. If we have our first exam, and it turns out I'm just making this number up. The average is usually much higher than this. Don't worry. So the average score on the test is 74. The scores are bell-shaped. The standard deviation is 4. What I want you all to do for me is find the 3 different breaks where we're going to get 68, 95, and 99% of the scores. I'm going to put 3 minutes on the stopwatch here. As soon as you feel like you have one of them, like between what 2 scores we get 68% of the data or what 2 scores between we get 95%, you can type it into the chat, or you could just speak it straight into the microphone. Oh, let's see. We got Moshe already. Oh, Moshe wants to bet on this. I like that. Moshe says category 1, 70 through 78. Next one is 966 to 82. Moshe, looks like you've done pretty well with this. I'm going to go ahead and I'm going to roll through the screen. Moshe's correct. When we're looking for 68% of our scores, 68% is going to take us back to, we have to get 1 standard deviation above and below the mean. When we plug in our values, we're going to be between 70 and 78. So that means if you took the test, 68% chance you scored between a 70 and a 78. Any questions on how we arrived at that range for the 68% part?
I'm confused.
Okay, Adriana, don't worry. If you freaked out, I'm going to freak you back in. So what we're doing is, remember how we said 68% of the data would be within 1 standard deviation of the mean? Okay, we know 1 standard deviation is a 4. So to get the high side of that range, we're going to take 74 and add on 4 to it, because 4 would be 1 standard deviation. That would bring us the high side of the 78. Does that make sense so far?
Yeah.
Okay, so to get the low side, what do I need to do to get the low side?
Subtract 4.
Excellent. You are going to be our empirical rule expert for today. Yes. So the next one, I'm going to stay with you for a minute. When we get to 95%, instead of doing x bar plus and minus 1 times the standard deviation, what do we need to change the 1 to?
Two.
Exactly. We're going to go with 2, and that's going to give us our next set of numbers. Any questions on how we got that 95% part?
Professor, just real quick,
Sure.
why are we going from using 1 to going to 2 again?
Okay, good question. And the answer is because for the second level, we're looking for 95%. And when we want 95%, we have to go further away from the average. So how much further? That's where we're going to get 2 standard deviations away. And where it's going back to is this part right here. The second statement said 95% of your data would be 2 standard deviations from the mean. That's how we knew that we had to add that quantity onto the X bar and subtract. Does that make more sense? You're welcome.
Okay. So then, would you ever have a situation where you would go like 4 standard deviations, or no, it would be only 4?
Well, that is a wonderful question. And the answer is absolutely. That's what's all going to be chapter 6 and chapter 8. Basically, what happens is you're getting into where outliers would be. And outliers can tell you a lot of things about stuff that's lurking in a data set.
Okay.
Yeah.
But
So
right now, focus on 2 and 3.
Say again?
So
Yeah.
for right now, we'll focus on just 3 standard, standard of deviation to the 3.
What's eventually going to be the furthest will be the 3, and we're going to have special names for them even. We're going to get to the part where that helps us classify values as being like outliers, unusual, or usual values. So you're definitely right. You hit on the gold mine. There's a lot there.
Okay, thank you, Professor.
You're welcome. Okay, so the third one, how many standard deviations are we going to add on? Everybody just give me a shout out all at the same time on the count of 3. I'll say 1, 2, 3, go.
12.
3.
Okay, good. I heard somebody say 12. I don't know where that came from. Okay. So if you took that test, there's a 99% chance that you scored between a 62 and an 86. Everybody feel okay, pretty comfortable so far?
So, Professor, is that always, like, if you give us a question like that, that's always what we're going to use is the 1, 2, and the 3, because you're probably going to ask 3 answers, correct?
Oh, that's another great question. And let's see, the best answer to that is for your first exam, you're going to be dealing mostly with those 3, the 68, the 95, and the 99. When we get into chapter 6, we're going to kind of blow this wide open and we're going to do a really deep dive on it. So for right now, it's just going to be those 3.
This is going to be on the test.
Yeah, this will be on your first test. I'm definitely going to give you a data set and I'm going to ask you to summarize some information about it with the empirical rule, or I will give you an average and a standard deviation and ask you where you can find like 95% of the data, 99%, and 68%. Any other questions before we move into a practical example of what we're seeing on the screen?
So just to reiterate, for empirical rule, it's always 68%, 95%, and 99%. Those
You are
3.
exactly correct. Yeah. Now, in case you were wondering, because you might have thought about it, like where would you go to find 92.01% or 85%? That we're going to do all in chapter 6. These are like the 3 main percentages.
Okay, cool.
All right. Any other questions, concerns, or anything that you want to ask before we move into an example of using it? Okay, so we're going to say that we're going to go into part 2 here. And part 2 kind of picks up where part 1 was. Part 2 was saying, we know that 95% of our data is going to be within 2 standard deviations of the mean. So I'm going to ask Adriana, she's number 25. Adriana, if we found a data value that was more than 2 standard deviations away from the mean, would it seem a little weird to you, do you think?
I think so.
You are exactly correct, because we know most of our observations, most of our values are going to be within 2 standard deviations. So what do you call stuff like that? And answer is they're unusually high or unusually low values at that point. So real creatively, we're going to call them unusual values. And Teddy's next, Teddy number 26. So Teddy, if 2 is unusual, what do you think happens at 3?
It's even more unusual.
Okay, what do we like to call, do you think, even more unusual?
Weird.
Okay, well, we have a special name for the weird. We're going to call it outlier. So this we would finally consider to be what we would call an outlier. And I have a really interesting question for everyone. This is for anybody that wants to answer. If you found an outlier in your data set, and you can just answer this on the chat window, who thinks that we should remove it from the data set? If you think remove, you can just write remove or yes, pull it out. Who thinks like we should keep it in the data set? Tell me which one you think we should do. Okay, somebody's saying keep it in. Remove. I'm gonna give it another few seconds for people to type stuff in. Okay, remove. So we're a little bit split here. A lot of people want me to take it out. They want us to remove it. So our fast answer is, should we remove it because, you know, it's an outlier. It should not be in the data set. Well, better take it out before it screws everything up, or keep it in the data set. Teddy says keep it in. It's part of the data. Why start distorting our data by removing things that were part of it? The answer is we want to investigate. Like, you don't know what the data value is doing, if it was a mistake, or if somebody was typing a 3 and they sneezed and they hit 10 and they just didn't notice it. It could be alerting you to something really important going on in the data. And we just want to find out what happened with that outlier. Like, should it be there or should it not be there? Because it could be that you noticed something that's really critical. Nobody else had caught it except the statistician. They were the first to notice it being reported. And I'm not going to ask you on the test, like, what should you do when you find an outlier? This is just so you know, if you're working with somebody, you're doing research, you see what's an outlier, we just want to investigate. Okay, and let's take a look at one other thing. Now, there's a something special we could do with the empirical rule, an application of part 2. And I can only see about 4 or 5 of you at the same time. If we were in the class, I would see everybody. So I want to make sure we're all doing okay. If you feel like you're good to go for an extra 5 or 10 minutes, just throw something in the chat that says, keep going, I'm feeling good. If you feel like you're just overloaded, you saw all this Chebyshev, all the empirical rule, like you had all you could take, just say stop, just so I know where people are feeling. Okay, somebody says it's along the same lines. That's a good question, good point. It's taking what we're doing now and it's gonna kind of bring it up to the next level. We're gonna get into some formula stuff. We're gonna start to generalize things. I'm just gonna give another few seconds in case anybody was just typing, they were trying to get something in here.
Professor, I guess I was the only one that said stop because I'm not too comfortable with this yet.
Okay, do you have any specific questions that I could help with?
No, I guess I just need to practice it more.
It's going to be almost one of those types of things where when you're doing the question, it's mostly going to be plugging in from the numbers. And I see a couple people saying, somebody is saying, stop. I see that, Teddy. So here's what we're going to do. We're pretty close to the end, so we'll stop at the part 2. The next thing that we were going to do, this is what it starts to look like on the screen. It loads us up a lot with, I'm going to try to get to, it loads us up with a big set of formulas. We end up comparing 2 Z formulas, and it might be a lot to observe all in 10 minutes. So I'm going to back this all the way up to where we just were. And some people are probably having vertigo right now. I'm moving a lot of things all around on the screen. I'm just going to park it at the last thing we said. Okay, I'm going to just stop there. We'll go in, we'll do the application of the empirical rule in the next class because it's going to get us into a lot of really special things about formulas, and we're going to have to do some generalizations. So just to wrap up some of the major items, we talked obviously about some variance and standard deviation stuff when we started off in the class, and we had a chance to review some of the symbols. Keep reviewing all the symbols in the index sheet of your notes because while you can look it up, we're going to have formulas that get really complex and you want to know how to use them by memory. You don't want to have to start to keep on looking up the symbols all the time because it'll really slow you down after a while. We talked about how to use the Chebyshev theorem, and I'm going to go to Teddy because he's next at number 26. Teddy, what do we need from the question to be able to do a Chebyshev theorem?
Got to say at least or minimum.
All right, nice, very nice. At least or minimum, and it has to give you what 2 numbers, Mariah? Mariah's number 27. Mariah, can you hear us? Okay, don't think Mariah can hear us. I'm going to go down to Aaron, number 28. Aaron, what 2 numbers is the question going to have to give us if we want to do a Chebyshev?
I'm trying to think. What 2 numbers does it have to give if you're going to do a Chebyshev? The average and the standard deviation.
Excellent. All right. Well done. And I'm going to bring us to number 29. That's Anna Marie. Anna Marie, if you're thinking about doing an empirical rule, what's the one thing you have to know before you start using your empirical rule?
It needs to be bell-shaped data.
Awesome. Yeah, it needs to be bell-shaped. So you mean if somebody gives you data and they say it's skewed, go find me 95% of the data, you're pretty much out of luck. Okay. And let's see. Carson. Carson's number 30. Carson, if you're going to use the empirical rule, what do you have to know from the question to operate it? Besides bell-shaped, like what numbers do they have to give you? And I don't hear Carson, so I'm going to go down to Michael. Michael's number 31. Michael, what numbers do they have to give you? I don't think that's Michael, but they just turned on their mute switch, so that's fine. I'm going to go to Victoria. Victoria, what are the numbers?
Question for me, please.
Yeah, sure. If you're doing empirical rule, what would they have to tell you in the question? Like what kind of given information?
Hold on 1 second.
Okay. The hint is it's right on the screen in front.
That's kind of funny. The standard deviation.
Well done. Yeah, standard deviation and the average. Okay. So the takeaways that I want you guys to remember from today about the empirical rule is it has to be bell-shaped. What Victoria just told us, I have to know an average and a standard deviation. And the number of standard deviations we have to go to get the three different percentages, the 68, the 95, and the 99. And what we can call an unusual value, and where do we find those? I mean, that didn't make sense. What we call an unusual value, we call them unusual. Where you find an unusual value, that's 2 or more standard deviations away. Where you find an outlier, 3 or more standard deviations away. So those pieces about the empirical rule. I don't think we would have had enough time to finish it today, and I don't want to rush it because we're doing this online, and I think you absorb a little bit less in an online lecture than you do when you're doing the class. Any questions before we mention where the homeworks are? Okay, so the homeworks, you guys are going to be practicing a whole bunch of Chebyshev exercises, and the homework, see if the homework is going to be on page 140. You have a whole bunch of Chebyshev questions circled in red. There's probably like 8 or 9 of them, and it's going to practice you up really well on everything you need to know. When we come in on Thursday, we'll talk about the empirical rule, and then we'll be just about done with the chapter at that point. If anybody else has any questions on anything, I'll stay here for a few minutes. Otherwise, great to be with you here. Always a pleasure. And we'll see each other again on Thursday.
Thank you.
Thank you, everyone.
Professor.
Thank you, Professor.
Great afternoon. Thank
Thank
you.
you, Professor.
Thank you.
Thank you. Go out and have some fun. Well, I mean, I know it's hard to do now.
I did have a question on the empirical rule.
Sure thing.
Really just about like, how do you, I mean, the question that you had for part 2, I didn't understand how you got the answers you got.
Okay, let me see if I can back up. You mean this part right here?
Yeah.
Okay, so what we were doing was we were saying if we took a test and the average was 74 and the standard deviation was 4, and we knew that the scores were bell-shaped, we were trying to find the 3 different categories or the 3 different ranges where you would get 68% of your scores, like 68% of the scores are between what 2 numbers, 95% are between what 2 numbers, and then where are 99%. And the only thing that we have to go on is what's in this screen over here. It's telling us how many standard deviations away we need to travel to find those specific percentages. So to capture the first one, if 68% of the data would be 1 standard deviation above, 1 standard deviation below, that means what we're going to do is we're going to take that X bar plus or minus 1 times S, and we're going to put the information from the question, the value for S and X bar in there, and it's going to come out to be 78 on the high side, 70 on the low side. The high side was saying 74 plus 1 standard deviation, which is 4. 74 plus 4 would be 78. Does the high side make sense?
Yeah, it does.
Okay. So the low side would be 74 minus 1 standard deviation length, which is a 4. So it's going to bring it down to 70.
And then the high side would be, you would go start at 99?
No. You're going to always start at the average.
Okay.
The average is 74, and then you're walking different numbers of standard deviations above it and below it.
Okay.
So that high side was 74 plus 1 standard deviation length, which was a 4. The 74 plus the 4 will give you the 78.
Yeah.
And then the low side was 1 standard deviation length below the average. So 74 minus the 4, which was 70.
Okay.
Better?
Yeah, that makes a lot more sense. Thank you.
Good. Well, I'm glad you asked, because when we get into chapter 7, we're going to use the same principle to do a lot more estimation techniques.
Okay. Well, thank you so much. Have a good day. I'll see you Thursday.
You're welcome. Have an excellent week. We'll see everyone on Thursday. And any other questions from anyone else?
Professor, I'm gonna stay here because I want to talk to you about next week, but I'll wait till everybody gets out.
Okay, I'm going to turn off the share function then. And I'm going to stop recording too.